Today we're going to discuss how to get the last of the different methods we have been using in order to evaluate a project. The third one is known as the equivalent annual cash flow analysis. If you recall, there are two methods we have discussed so far. The first one is known as the net present value. The second one is the internal rate of return. This third method is probably the least used. It is not as common, and there are different reasons for that. We can discuss them. But it is important for you to get a good idea of what this method is about. If you recall, once again, the net present value is basically to convert all different cash flows that you'll have, past and future, into a present amount. For instance, let me say you have this project where you are investing 1,000 American dollars, and you'll be receiving in 1, 2, 3, and 4 years different amount of money. So assuming these are the amounts you'll receive, net present value, simple bit, is all you need is a discount rate in order to convert these different cash flows into a present amount of money. In the case of an equivalent annual cash flow analysis, what we do is we need to convert again each one of the different cash flows that we have into a uniform series. There has to be a continuous amount series. Of course, as an analyst, it is important for you to determine what the meaning is of this equivalent annual cash flow thing. You want to convert, let's say, these different flows into either 5 payments, 4 payments, 3 of them. It is your decision. The important bit is that the interpretation of the analysis will be as follows. The equivalent annual cash flow analysis will be like saying, in average, I'll be either having a profit for this amount or having an amount on spending equivalent to this amount. Once again, as an analyst, you can define if you want to convert all those different cash flows into 5 different payments, 4 different payments. It is up to you. Let's assume I want to identify the size of 4 equivalent payments for this specific project. What I am going to do now is I need to convert each one of them into a similar amount. An amount of money that has to be exactly the same over these 4 years. So instead of having this one, I want to identify 4 different payments for a similar amount of money. But those 4 payments have to take into consideration not only the money I'm receiving, but also the money I'm investing. In order to do so, we have what we call the equivalent functions. Of course, you can use the tables, you can use the financial notation, and even today you can use the tools that are built in basic software, common software, as it is the case of Excel or probably a financial calculator. I'm going to do it through the long way, through the long process, but once you do it, once you know how to get it, then you'll have plenty of options how to get this specific analysis. So let's start. Initially, I want to convert this investment of 1,000 pounds. That's not a big problem because so far we have different formulas that help us in order to get that value for a particular amount of money. If you recall, I have 2 different financial functions that allow me to get or to convert any amount of money as follows. I can convert this amount of money into 4 different payments using the A given P function. That is, I can convert these 1,000 American dollars into 4 payments, uniform series, starting here. Remember, anytime you have this specific function, the first equivalent, in this case payment, will start 1 year after the amount of money that I got to convert to. So, to convert from actually. In this case, as it is an amount of money you are paying, you are investing that money, I'm going to multiply this bit times A given P, and the interest rate, let's use the 8%, and I want to convert into 4 different payments, with the first one starting 1 period after. I can convert into 4 different payments starting here, or probably starting in 2. It is up to you. So far, based on what we have, you can convert to any number of payments starting wherever you want. In this case, I assume I want to convert all those different cash flows into a uniform series starting in t equal to 1. Therefore, I want to convert those 1,000 pesos into 4 different payments. Remember, the most important bit is where is the first payment going to be located. And in this case, if you recall the concepts we have covered so far, first payment is going to be here. Because the money I got at the moment, these 1,000 American dollars, are here in t equal to 0. Therefore, the 4 payments will start in t equal to 1. Let's say I call it 80. And the initial bit is this one. The amount that you get, then you need to multiply those 1,000 times. In this case, the value for that factor is equal to 0.3019. Not a problem, an easy one. That's 301 with 90 cents. What about that one? Those 400 pesos or dollars. First of all, if you see, I have an increase from 300 to 320, and then 370, and then 400. So it is not a constant gradient. It is not a constant increase that I can use the gradient that I have so far. So I need to work each amount of money at a time. This bit there, which coincides, it is given at the same time as the last equivalent flow that I want. Therefore, I can take advantage of the financial function that I have, which is A given F. To do so, I'll be converting an amount of money that is given in a future time into a number of payments where the last payment is going to be given exactly at the same time as the money I'm using to. In this case, it is a positive flow, so I'm going to convert that one by A given F, the same 8%, and 4 is going to be the value of the number of payments that I want. If I review my tables there, you'll see that that value is equal to 0.2219. It is a positive amount, and therefore, what is the meaning? The meaning is that instead of having those 400 pesos, I can have one payment of 88.76 here, another one there, another one, and another one. 4 different payments, each one for 88.76, with the last payment, the last money that I'm receiving, given here, exactly at the same time as the original period of time that I'm moving this money from. So far, I have moved, or I have converted this amount and that one. However, those 3 are not easy to move. What if I use something like this? What if I do those 300 times A given P? That's a possibility. However, if I use this option, the initial payment is going to be expressed here in t equals 2, when t equals 2. That's not what I want. What I want is the first payment to be given here. So, as I only have A given F and A given P, I can either move this bit backwards, 1 period, or move it ahead in time, 30 periods. It is up to you. What I'll do this time, I'm going to move this bit backwards. How do you do it? You just divide the amount by 1 plus the interest rate to the power of the number of periods you're moving that bit down. In this case, I use the financial notation, which is P given F, which is the function I have whenever I want to bring back any amount of money. The result of this operation is the equivalent amount of money 1 period before those 300. And that is equal to 277 with 78 cents. But that is not what I want. What I want is 4 payments to be uniform and continuous. This is not that. This is 277 is equal to those 300 expressed. Sorry for that. I could have this 277.78 here, or the 300 there. So if I cancel those two, those 300, I could have 1 here. But I need to convert that bit again. How do I convert it? I already did it before. Times A given P at the 8% times 4. And I knew already this is equal to 0.3019. If I do the operation, you'll get to see that this bit is equal to 83.86. A similar thing has to occur with those two. First, I move the 320 back 2 periods. PF. Note that now it is 2, because this one is moving backwards 2 terms, 2 periods. And then the result, I multiply this bit, probably this is not the best illustration, I multiply this bit times A given P, 8 in 4. Because the result of this operation, which is close to 274, will be the amount of money here. I need to convert into 4 different payments using this specific function, A given P. And this is equal to $82.83. The last one, I follow the same procedure, but I bring it back 3 periods instead of 2. And then I multiply this bit times the same function. And that is equal to so instead of having this bit, let me try to superpose another piece of paper. If instead of having the flows that I have there, now I have, let me move this bit. Instead of having something like this, 320, 370, and 400. Instead of that bit, what I have so far is one negative amount, because this one is negative, for 301. Each one for 301 and 90 cents. And I have 4 positive amounts of money. The first one for 88.76. The second one for 83.86. Let me be sure, yeah. A third one for 82 and 83. Of course, not the most neat diagram, but I guess the concept is right. 82 and 83. And the last one up there for an extra 88 and 67. If you add up all of those amounts, this will be positive, equal to 42.22. So, this bit is equal to 4 payments, one each year, for $42.22. Looks different. It is different. But the interesting bit is you have converted the different amounts of money into an equivalent uniform series. And that gives you an idea of how your flows of money will look like over a period of time. Of course, remember, this is the important bit. The first or the initial equivalent amount of money is given in t equal to 1. Will it be possible to convert this one not into 4 or 5, something like this? Of course it is possible. Of course you can do it. Right? Actually, you can do it not in 4. You can have it in 3 or 2 or 1 actually. Indeed, having all these flows in t equal to 0 is what we call the net present value. If you move all of them to this point in time, that's PPN in Spanish, net present value in English. In this case, if you convert into an equivalent amount of money, you are talking about this annual cash flow analysis. I hope it is clear. I hope it's been useful. And remember, stay in touch with me. Please, if you have any question, just send me an email. I'll be happy to answer the questions that you have. Thank you.